Greetings and welcome to another VMBlock screencast. In this screencast I'm going to show you how you can write a contract almost entirely in YAWL. Let's take a look. So first of all, what I'm going to do is to make it easier to test this, I have written an interface which has the functions that we want to call on our YAWL implementation. So the interface is Fallback interface demo, and it has two functions, get123, which returns a uint256, and get999, which takes in a parameter of a uint256 and returns a uint256. Then I've got a function here, or sorry, a contract here that basically takes this as a constructor, the target, which will be our YAWL contract, and calls into that target through the interface. So what does the YAWL contract look like? Well, this is it here. This is the entire contract written on the screen. And as you can see, it's pretty much all in assembly. So there aren't any interfaces, there aren't any functions explicitly defined in Solidity. This all relies purely on the assembly code. So what's going on here? Well, what happens is in the first line here, we need to load in the call data, and we load this in 32-byte words. So we call data load, passing in 0 to get the call data. Now, the next line is a trick where you'll see a lot where you can extract just the function selector from the call data. And the function selector is always going to be the first 4 bytes of the call data. And we shift right by 224 bits, as we are doing here, such that the function selector data is at the rightmost portion of the value that we want to check against. So in other words, we are now able to use this pattern, a switch statement, where we just simply check the 4 bytes of the function selectors that we're interested in. If we didn't do this, I'd have to have a lot of zeros at the end here to get this to work, which wouldn't be very readable. So I use this switch statement, and in YAWL, what happens with the switch statement is that it will check against the different cases. So the first case is this one here, where we are checking against this function selector essentially. Now this happens to match the function get123, and it's calculated using the getchat256 of this function name string. So it returns this value. So this is the function selector, and what we do is we call into a function defined in YAWL called return value and pass in this value 123. The return value function is defined here in the YAWL code, and it simply takes the value, which is 32 bytes, and stores it at address slot 0, and then returns it. Now remember, one of the reasons why we use memory is so that we can return values back to the caller. So we store the value and then we return it. Very common pattern to see. And of course, the return statement here in YAWL doesn't behave as you might expect. It's not returning back to the YAWL code that called it. It returns back to the smart contract that called into this smart contract. So it calls back to the caller. In other words, it's, in this case, because it came into here, it's going to come back to this context here, the calling contract. So that's the first example. The second example, which is the get999, is almost the same, but we, instead of hard coding a value to return, we call another function in YAWL which returns the value that we want to return. So this is just done so that we can see an example of returning a value in YAWL. So this value, determine different value, returns this value R. The value R is defined by, or set, I should say, depending on the first argument of the call data. So we load the call data again, but this time passing in 4, so we skip over the function selector part. And we get the arg. This is going to be our first argument. And we just check if it's equal to 999, then set R equal to 999. And then it's going to return it. It's going to return it because we've got this leave keyword here. Now this leave keyword allows us to return back to the YAWL code that called this function, which is here, which then returns into this function, which then returns back to the calling contract. Otherwise, it's going to set R to 888, and we don't need any leave or return here because it's going to go back here and it will set 888 here and return it to the caller. So that's the walkthrough of the YAWL contract code here. Let's test this out. So in order to test this, we need to first deploy the YAWL contract. So let's make sure that's selected and click deploy. This is the YAWL contract. We can have a look at the instance, but there's nothing much here. We can't interact with it as you'd expect with Remix because there are no functions defined except the fallback function. So to make this easier to test, we can deploy this contract here, the implementation, and pass in the address of the YAWL. So I get the address of the YAWL contract and I pass it into the deploy, and that will deploy the implementation contract, which we can test, that has the function names defined. So remember, this will be called here into the target, which will go into this assembly. So let's try this. And as you can see, it returns 1, 2, 3. What happened? Well, we called this function, it then called this function on the target, which came to the fallback function and loaded in the call data, shifted right to get the selector, went into this case statement, it matched this, and then it called this to return 1, 2, 3. So the same thing with this function. If we pass in 1, 2, 3 here, we get 8, 8, 8. That's because, of course, it calls into this, which calls this, and it checked this value here, the first argument, and noticed it wasn't 999, so it set it to 888. But if we pass in 999, then we'll get 999 back. So that is our demo of a smart contract that is written in YAWL almost entirely, and how to deploy an implementation contract using an interface in order to call into our YAWL contract as shown. So I hope you enjoyed that demo, and I'll see you in the next video.